Hey there everybody, we're going to keep this one nice and short. We're just doing inverse trigonometry. So hopefully by now you have a good handle on regular trigonometry and how to solve for side lengths when it comes to those. So now we're going to go into the inverse trig. And the difference with these is that the inverse trigonometry is going to solve for our angle measures, okay? So we know our trig functions already, and we saw that when we use them, we would substitute a value in for A if it was like tangent of A. And we put an angle measure in there, and then it would equal a ratio, and one of the ratios, or one of the top or the bottom parts of those ratios, would be an x or a y or something like that we would have to solve for. So now the inverse trigonometry is going to solve for the angle measures. So we're going to be able to come up with a ratio of like 5/7, but the difference is it's going to be like tangent of A equals 5/7. So we're not going to have a value that's going to go in for the angles. We're going to actually be solving for that. And we're all going to utilize our calculator, so please make sure you have that ready to kind of practice with, okay? All right, so our trig inverse functions, we're letting angle A be an acute angle. Remember, there's two acute angles in a right triangle, so it could be either of those acute angles. What the inverse tangent, if tangent of A is equal to x, so we know that tangent of A is going to be some ratio. What we're going to do is do the tan inverse of x, and when we put that into our calculator, what it spits out is the actual angle measure. The same thing is going to happen for our inverse sine and our inverse cosine. So everything is the exact same thing. And I'm going to show you in a moment on the graphing calculator where the inverse functions are for our sine, cosine, and tangent. If you have anything else and you cannot locate it, you're typically looking for something that has with the -1 there. I know that a lot of the TI things, they have that sitting above the regular sine, cosine, and tangent. Typically it's going to be found in that same exact area. So you're looking for that sine inverse or tangent to the -1. I'm sorry about that. Okay, so let's go ahead and move on. Essentially, if you look at it, a specific example here, so we're looking at where angle A is, so this one right here, we can find the measure of that angle by doing this tan, sine, or cosine inverses using the appropriate sides. So for example, for tan, we know that it's side opposite over the side adjacent. So here's our opposite and here's our adjacent. So the opposite side is BC, the adjacent side is AC. So if I put it as a fraction and then do the tan inverse and put that fraction into that function, then it will spit out the actual angle. Same thing happens with sine and cosine. Oops. All right. So, like I said before, to use your calculator, you can see the graphing calculator right above the sine and the cosine thing. That's where our values are. All right. So take out your calculator and let's kind of walk through some things. The first thing I want you to do is type in your calculator the sine of 27. Okay. So when you type in sine 27, you should be getting the value of about 0.454. Okay, now 0.454 is a ratio that if I were to give you a triangle that had an angle of 27 degrees, the opposite over hypotenuse would actually be the fraction of 0.454. So let's see what happens when you use the inverse of the 0.454. So what I want you to do right now is, using your calculator, type in sine to the -1 of 0.454, and let's see what you get. All right, so after you've done that, you should have gotten about 27. Now, the reason that it's not exactly 27 is because the 0.454 was rounded. Okay, so just keep that in mind. But it's about 27, and that's always going to happen. Anytime we have sine of 27 or an angle of 27 degrees, the opposite of hypotenuse should be 0.454. Okay? So hopefully that kind of gives you the understanding of what's going on here relating those two things. They're inverses of each other. And you'll learn a lot more about inverse functions when you get to Algebra 2, but they do the opposite of each other. Okay? All right, so let's go ahead and do a couple more examples with that. So sine of A is 0.87. You need to be able to find the angle measure. So what we need to do is flip where A and the 0.87 is, and when you flip that, then it becomes the sine inverse, okay? So that's how we work these problems. So it went from regular sine to sine inverse. And we're going to put that 0.87A in, or 0.87 in, and hit enter, and you should get about 60.5 degrees, okay? So these are the most basic problems when it comes to trig inverses. We're going to solve a problem where we actually find angle measures, okay? All right, so let's do it one more time with the cosine of B is 0.15. That means if I were to have a right triangle, and here's B, I know that this is some number, let's say for the sake of this is 15, this is 100, okay? If I were to want to go find this angle measure, and if I did the cosine of b itself, it would be 15 over 100, because that's adjacent over hypotenuse. So now I want to find an angle measure. If I were to take the inverse of it, that means that that angle there is 81.4 degrees based upon the fact that we know that the adjacent hypotenuse is 15 over 100 or something that relates it to it like that. Okay? If you're still not understanding what it means to do the sine and cosine or tangent inverse, please let your teacher know. We can explain a little bit further. But the whole purpose of these is to go through and find the angle measures by utilizing those pieces. Okay? So let's actually do it. We're going to find the angle measure of an angle, and I'm only going to do the one. And if you need more examples, please, again, let your teacher know. So we're trying to find the measure of this acute angle A. We already know what B is, okay? So when you're doing this, you kind of want to identify, well, what am I given? So the 15 is my opposite, and the 20 is my adjacent. And so when I go through my sine, cosine, and tangent, which one uses opposite and adjacent? And so thinking back, okay, we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and so that's the one I want to use. Okay, I see that opposite over adjacent. So I'm going to set it up, thinking back to the last lesson that you learned. When you find the tangent of an angle, we just set up their ratio. Okay, so we have tangent of A is BC over BA, or in other words, tangent of A is 15 over 20. Now you could reduce it if you'd like to, but you don't have to. When you're finding the angle measures, we can go ahead and just do the inverse with them and then substitute it into your calculator to find it. As you can see here, it doesn't matter if you did tangent of 15 over 20 or the tan inverse of 3 over 4. The result is going to be the exact same thing. Okay, so when we go ahead and substitute that or plug that into your calculator, this becomes a nice plug and chug. You plug it into your calculator, chug out a number. We get the value of 36.9 degrees for the measure of angle A. So I could now use this to find the measure of angle C if I wanted to as well. The difference was it'd be tangent inverse of 4 over 3. I can also use the fact that I know what angle A is to find the measure of angle C. And we're going to use that kind of knowledge in our next lesson. But let's just focus now on our tan inverse, sine inverse, and cosine inverse. All right, go ahead and hit the stop button and start your practice.